my name is Kim Mankosa. I'm one of the lead sales engineers here at ACT. Today, in our Engineering with Markers video, we're going to talk about ACT's Loop Thermosyphon, and particularly how it works within the energy industry. So a lot of energy conversion techniques utilize a generator or something that spins to create a magnet or to use a magnetic field to induce an electrical charge on a wire. Now, with all of that spinning and all of that movement creates friction and thermal losses within that friction. So how best do we maximize the effectiveness of our energy conversion device when we have this thermal energy loss due to friction? Well, we want to use something like oil or something to reduce the amount of friction in general. However, the oil is still absorbing thermal energy. So in order to make the energy conversion more efficient, we need to remove that heat from the oil. To do that, we can use ACT's Loop Thermosyphon. Now, the way Loop Thermosyphon works is very similar to a heat pipe for those of you who have experience with heat pipes. A heat pipe operates in a closed system. This means that it operates along the saturation curve of the working fluid. It also leverages the latent heat of vaporization. And both liquid and vapor are present in the heat pipe at all times. At the hot spot, the liquid vaporizes. That vaporized fluid moves to the area of lower pressure or cooler area. The vapor then condenses and returns back to the hot spot either via gravity or the wick. Now, if it's gravity, it's a thermosyphon. So what's the difference between a standard thermosyphon and a loop thermosyphon? Well, here in this picture, you can see that our liquid and our vapor move in opposite directions. With heat pipes and thermosyphons, this means you hit the entrainment limit or the flooding limit. And that's where if you have high vapor pressure, high vapor velocity, you're going to actually pull some of that liquid out of the pipe or out of the wick, and so it won't return back to the hot spot. With a loop, you never have the same direction or counteracting flows. You always flow in the same direction, which means we're actually able to handle higher amounts of power. So let's take a look at how the loop works. Here, we have our evaporator block. So say we have hot oil coming in here in a heat exchanger at this point. Then we have it cooling down because it's going to be exchanging with our loop thermosyphon fluid. Again, completely in a sealed, closed loop and operating along the saturation curve of that working fluid. So at the hot spot, the working fluid is going to vaporize. Now, the latent heat of vaporization is awesome when you look at the working fluid. It's the amount of thermal energy it takes to convert from a liquid to a vapor phase. And to think about it, water's latent heat of vaporization is 2,257 kilojoules per kilogram. Now that's compared to its specific heat, which is the amount of thermal energy it takes to raise at 1 degree C, which is 4.187 kilojoules per kilogram degree C. So that's very significant, going from 4 to 2,000. And that's what we're leveraging here. Now, with most of our loop thermosyphons, we're not using water. We're using a dielectric fluid or some other refrigerant in order to do a wide variety of temperatures and be able to handle different components. So we can do exchanges in electronics where you don't want to worry about breaking and having any working fluid drip. Dielectric fluid works for that. So again, here, we're vaporizing at this evaporator plate. Then moving through the tube, the vapor is going to be flowing against gravity because of vapor pressure, and then going up here to the condenser block. Now, the condenser can be either a liquid-to-liquid interface or a liquid-to-air interface. Really anything, we can customize it for you. But the point is to condense the working fluid back to a liquid, and then the liquid returns via gravity to that hotspot. With these loop thermosyphons, we've been able to field upwards of 75 kilowatts of thermal heat transfer and making a very effective, very efficient, and also passive solution. So if you are interested in optimizing your thermal management system, reducing your parasitic energy losses by looking at a completely passive solution, contact ACT.